Hello, welcome once again to your favorite subject with Seranga. Today I'm representing Group 5 from the PGDE class of 2025, and we are studying our favorite subject, that is statistics. And today we're going to be looking at the chi-square test. Have you ever wondered whether there's a relationship between the degrees boys and girls choose in college? If you're wondering, just like me, let's dig right in and make sure we make use of the chi-square test and understand what is happening. I'm just sharing my screen in a moment. Let us look at what is happening here. Okay, so the chi-square test was developed by Carl Pearson in 1900. It's been a while. It's been around for a while. And it is a non-parametric statistical test that is used to determine relationships between categorical variables. And we actually find two types of tests under the chi-square test. That is a test of association. Are two variables related by any chance? And a goodness of fit samples. Do they follow an expected pattern? Okay. What are examples of categorical variables? Gender, the choice of subject, yes or no. And we also use chi-square tests when we're dealing with very small samples, skewed distributions, as well as, categorical data. When we want to check whether there's an association between two variables, like what I said, gender, the choice of subject, that is an example. And this is what we're going to be doing today. Let us check the association between two variables. We also find a goodness of fit where we want to check if the sample data, the sample drawn from a population follows an expected pattern. There are some key terms that we may want to learn as we do our calculations. That is the observed frequencies, the actual data collected, how many girls actually enrolled for the mathematics program, how many did we expect? And in our test of independence, there are degrees of freedom. We are going to use this in calculating our critical value later on. And finally, the main man, the chi-square statistic, it measures the difference between observed and expected values. All right, let's look at our example. Do boys and girls choose different degree programs? We're given some data here. Some call it data, we call it data. The difference is the same. 117 boys chose to do mathematics and girls were 24, making up a total of 141 in the mathematics program. On the other hand, 63 boys chose to do marketing, and then 56 girls chose to do marketing, giving a total of 119. And then our total class, or the total number of people we're dealing with here, were 260. So we've got an H0, if you've ever heard about this animal. It's called the null hypothesis. And in this case, our null hypothesis says there's no association between gender and degree choice. There's nothing about gender that made the 56 girls choose to do marketing. And then our alternative hypothesis would be to say, yes, there is an association between gender and the choice of program. If you look to the right of our slide, there is a contingence table. This is how our data is arranged when we have more than one variable. So let's take X1 to be boys, X2 to be girls, Y1 to be mathematics, and Y2 to be marketing. You put in the totals, I'll show you just now. And in the brackets, you see there, that is the expected frequency. Yes. So if we are calculating our expected values, we use the formula row total by column total divided by the grant total. As you can see from the previous slide, the row total for mathematics is 141. But we're going to find a column total of 180. We multiply those two, we divide by 16, we get 98. We're going to pause a little bit, grab your pen and paper, and let's find all the expected values from this contingents table. I'll pause a bit for you to see the values. All right. Yes, let's carry on now. If you look at the example calculations that I did for you, our expected values are 98, 82, 43, and 37 for the corresponding observed values of 117, 63, 24, and 56. And for us to calculate our chi-square statistic, we want to come up with the sum total of the observed values minus the expected values. We square the results and then divide by the expected value. So in this case, it's supposed to come out in a table like this. Number one, number two variable, this is our male and female. Sorry, let's just go back again. And then what did we observe? What did we expect? And our 117 minus 98, we put it in the fourth column. Then we find our test statistic for each row, and coming to 3.68 in the first row, 4.40, 8.39, and 9.76. If you take out your calculator, you're going to add and come up with a chi-square statistic, the calculated one, being 26.24. And having come this far, how do we determine whether the variables are related or not? Let's go to the next one. Remember earlier in the lecture, I talked something about finding the critical value and finding the degrees of freedom. We have rows with columns. Remember, with our variables, with 2 rows and 2 columns. Let me just come back slightly to the contingents table. You could see that we've got 2 rows and 2 columns. And 2 minus 1, this is for the test of association. The formula that we use for degrees of freedom is rows minus 1 times columns minus 1. We get an answer of 1. And using a significance level of 0.05, our critical value then would be x squared for significance level of 0.05 times 1. Then using our chi-square tables, we then grab your chi-square tables that I gave you in the last lecture and preparing for this one. It comes out to 3.84. Comparing what we calculated in the previous slide, remember we got 26.24. We now have the critical value being 3.84. And since our chi-square statistic is greater than the critical value, we reject the null hypothesis. Who remembers what the null hypothesis said? It said there is no association between gender and degree of choice. And because the chi-square statistic is greater than the critical value, we conclude that gender and degree choice are associated. Are we together? So, as we round up our lecture for the day, the chi-square test helps determine if categorical variables are related. And remember, always remember, before I run out of battery, always remember that if x squared is greater than the critical value, we reject the null hypothesis. What's the life or practical use of the chi-square test? We find it a lot in social sciences. We find it a lot in marketing. We find it a lot in health studies and more. Let's pick something. Today, we are in the season of Valentine's Day, something that is not for your age, but we could test if there is a relationship between the types of presents bought by males and females. Would males buy cars better than females buy cars? Would females get flowers and the colors related than men? It's something that you could play around. Look at social sciences, scholarships. Is there a relationship between gender and the passes after A levels that people get when applying for scholarships? Look at health studies, disabilities. Is a disability generally related to gender? Those are things that we can actually look at. And at this juncture, I want to thank you all, invite questions, and yes, let us practice with real data within our PGDE class of 2025. Yep, we are all studying different areas of specialization. Let's look at it this way: Shona and history. Men and women who study Shona and history as their areas of specialization. Let's find out, is it related? Did your gender influence your choice of an area of specialization? I want to thank you all for this session and invite you to the next session where we look at the goodness of fit tests. And remember, whoever knows this better can understand the patterns. And if we do a goodness of fit test within our class, we can actually tell if our sample represents what people across the university may feel about the choice of degrees and the relationship to gender, or what we think. Look at starting times. We ask ourselves, what time do you want to start lectures? Does what we think is the PGDE class of 2025 reflect what the rest of the university thinks? Stay excited, stay curious to know. Let us use statistics to understand the world we live in better. Thank you.